Alright, let's start with the reactive protocols. We will start with the DSR protocol. Let us look at this network. This is having many nodes. Let us suppose S wanted to send some data to D node. S is the source, D is the destination. Okay, this S wants to send some data packets to D. So first step that we have to do is route discovery. Okay, node discovering route when it is needed. That is why known as reactive routing protocol. I already said it is a reactive routing protocol, that whenever S wants to send some data packets, only then it will discover the route. Okay, for this thing, see, I will ask my neighbor. They might know about D, so this will ask its neighbors whether they know about this destination. So how will it ask? It has to create one route request packet. Okay, node S asks about route to D by sending a route request packet. That route request packet contains few things. Those are unique ID, a list of node, source and destination. All these things would be like this. Suppose you created a packet like this. You are entering few things here. The first is the unique ID. Let's suppose this ID is 1. Okay, now source is S, destination is D. Initially this will be empty. Intermediate nodes S to D, all the intermediate nodes will be written here. Suppose from S we are passing this packet to C, then like C will be included here. Like if the route includes B or F, then those things will be included here. So all these things will be included in this. Initially this will be an empty list. Okay, now let us suppose S has created the route request packet. Now S wants to send this to its neighbors. The neighbors of S are A, B and C. Okay, this will pass to A, B and C. C will check the destination. C also don't know where is D, so it will insert its ID. So ID will be inserted here and in packet, and this packet will be broadcasted. That means this packet will be again forwarded. Okay, next C will forward the data packet to its neighbors. The neighbors of C are S, B and G. So it will broadcast the packet with its ID to its neighbors. Okay, now what will S think right now? I have already broadcasted a packet with the similar ID, right? Just now S has broadcasted the packet to C, A and B. So the similar packet again came to S, so it will discard the packet. Now what is the case with B? B has received multiple packets with the same ID, so it will discard the later packet. The later packet is the one that is received from C, so this will be discarded. So this is the situation right now. Now what does A do? Initially A received a packet from S, right? But it doesn't have any information about the destination. It will add its own ID here, and it will be broadcasted to its neighbors. That is, this will be broadcasted to S. So this will be broadcasted to S. S has already received something, so this will be discarded. Now let us look the case with C. C has broadcasted to its neighbors, right? S, B and G. S and B have discarded their packets. G, the packet that is sent to G is still remaining. Now here we have B. B don't have any idea about the destination. What will B do? B will add its own unique ID, send to its neighbors 1, 2, 3, 4, 5 like that. I think it won't send to G. It will send to C, F, A, S and J. Okay. Packet broadcasting will take place. Again, this has already received the packet. This also already received the packet. They both will be cancelled. Okay. Now what will G do now? G don't have any idea about destination. G will add its own ID here in the packet which he received from C. Okay, G will add, it will try to broadcast to I, H and F. Now, G has broadcasted to I, H, F as well as to C. Now again C will ignore this. F will also ignore this. It will discard because it has received multiple packets. F will discard because already received the packet. C will discard because it had already broadcasted the packet. Okay, next. I have only one node. Okay, this one G. Again, if it is sent here, this will be again discarded. Again, if H will send to this one and this one will be discarded. This one also be discarded because it has multiple packets with the same ID. Now we are left with F and J. Okay, now J will add its ID, that is J will add F here. It will pass the packets to its neighbors. F has added here F. Now this will broadcast it to its neighbors. This is broadcasted to the neighbors, and if you look at this node, D will check the packet and find its own address in the destination. D would know that this source wanted to send some data and it has discovered a route with B and F. Now what it will do, it will create a reply packet and it will send back the reply to the source. How would D know the path? Then how would it send the reply? See, we have this source, we have this destination, we have the intermediate nodes. Don't you think we can form a route from this? From packet D would know the packet is coming from S, B, F and D. This is the path the packet is coming. So it will reverse the path. It will be D, F, B, S. In this way, it will try to forward the reply packet. This is reply packet. Now this is the path, will be forwarded to F. Now again this will be forwarded to B, then this will be forwarded to S. After this, S will create now node S has the route to D. Yes, this is having the route. S will create the data packet. S will send this packet in this route. So this is the data packet created by S. Now this will be sent to B, then F, then D. Objective is completed. Our objective was to send a data packet from S to D, and this happened through reactive protocol. That means whenever it is needed, we have found a route and we have sent the packet through that route. Now let us talk about few problems in this. Suppose you have found out a route to the destination D. Suppose after some time again you wanted to send the data packets to the same node. Do you have to find this again? Suppose now you have sent the data packet to D. After some time again you wanted to send the data packet to D. S want to send the data packet to D. Does S has to find the route again? No, because if it is so, then that would be waste of time, right? Because route discovery would take some time. Again, this time has to be repeated. So instead, if that should not happen, then what we have to do is, once a route is found to a particular node, that route has to be saved in a cache memory. Again, route discovery process, it is not efficient. It is a very time consuming process. Node S will create a cache store, that is nothing but a store, route to D. In future, if S wants to send it, will get route from cache. And one more thing, let us take the one more problem that may occur in this protocol. Suppose in future, if this link is broken, then what will happen? Because if this link is broken and if S still believes that this route is good and if it sends the data packet, then these packets will be lost, right? So what happens if this link is broken? So if link is broken, route maintenance phase comes in. So what we have to do is, here we have to send a packet, that is repair packet. Okay, repair request, you can assume like that. This packet will be sent. This packet will be sent from from F to B, then B to S. Now S will understand, okay, this route has been broken. Now we have to find the one more route and it will update in the cache memory. So that's all about this DSR protocol. In the next video, we will look at the one more reactive protocol,